of a function is set of all the possible values of inputs for the function. So which means whenever I say input, if the function is y is f of x, so where x is my set of all the possible values of x. So in order to find the domain of any function, basically we need to remember the two restrictions on the domain of a function. Let us say my first example, I have something like y is equals to x plus 1 over x plus 2. So for sure, this will be a function. The reason why it's a function is for every input, you'll be getting a single exactly one output. Let's say when x is 0, your y or f of x would be 1 over 2. Let's say when x is minus 1, it would be y would be equals to, so when you substitute it here, so y would be minus 1 plus 1 over minus 1 plus 2, which is 0 over plus 1, which is 0 itself. So when y is positive 2, sorry, when x is positive 2, your y would be 3 over 4. Now, when x is negative 2, so you'll be getting y as something like negative 1 over 0. So any number over 0 is always undefined. So which means I'm giving some input, but I'm not getting any specific output. So we say at this point of time, we say this function is undefined when x is minus 2. So that is, which means whenever your function is in the form of fraction, whenever your function is in the form of numerator and denominator, the denominator should never be equals to 0. So that is the first restriction to find the domain of a function. In this case, the denominator is x plus 2. So this x plus 2 should not be equals to 0, which means 2 moves on to the other side. X should not be equals to negative 2. So which means I can say the domain of this function is, domain means all the possible values of x. X can be all the real numbers, but x should not be equals to negative 2. So this is how I can find the domain, and this is the first restriction I should be aware of. Now, if I talk about my second restriction, let us say I have something like y is equals to square root of x plus 1. So now when x is 0, so y would be equals to root of 1, which is 1 itself. Now when x is negative 1, so y would be equals to root of 0, which is 0 itself. Let's say when x is positive 3, so y would be 2. When x is, let's say, positive 8, y would be 3. So something like this. Now what happens when x is negative 2? So y would be root of some negative number. And if you type root of any negative number in your calculator, you'll be getting something like math error. Basically, these are known as imaginary numbers which doesn't exist, which are not a real number. And not only when x is minus 2, let's say when x is minus 3, when x is minus 4, when x is minus 5. So for so many values, your y would be root of some negative numbers. So root of negative numbers is called as imaginary numbers, and which are non-real numbers, and you can simply remember which is also undefined. So in that case, I'm giving some input, but I'm not getting any real outputs. So at these points of time, these cannot be my inputs. So in that case, what is the restriction that I'm going to say is, so whenever you have any function, and whenever you have a square root, and if you have any expression under the square root, that expression must be positive. Only then the value exists. Not only positive, it can also be 0. So in that case, in this case, the expression is x plus 1. So x plus 1 should be positive. So in that case, I can say x must be greater than or equals to minus 1. In that case, finally, I can say the domain of this function is x can be all the real numbers, but x should be greater than or equals to minus 1. So this will be the domain of this function. So these are the two restrictions that I should be aware of in finding the domain of a function.